Okay, that's good because otherwise the kids just keep looking you up and then they talk about your pets and it's weird. Alright, day 2 homework. And we're going to call this doing homework without calculator edition because I didn't bring a calculator with me today. Alright, number 1. You can buy used camping equipment from your friend for $80. Okay. I don't know what sort of friend charges you, but that's fine. Or you can rent a package for $40 per night. Either way, you have to pay a nightly camping fee, which is $20. And we would assume since that's nightly, that would be per night as well. And it doesn't matter which option we go with. How many nights must you camp, comma, for the cost of renting and buying camping equipment to be the same, where H is the number of nights you camp. Why is H the number of nights you camp? That's an excellent question. Alright, so we need some expressions here to figure out how much this costs. So let's start with buying it from your friend. So if you buy it from your friend, you would have to pay $80, but you only pay it one time. So we're not going to multiply this by anything, it's just 80. But we also have to pay the nightly fee, so plus also $20 per night. So that would be 20 times this mystery variable H for number of nights. Why would they use H? No thoughts over there? Why would H be nights? Nights. You think about that. Okay. Other option. Math makes absolute sense. Stop being difficult. Alright, other option. 40 a night. Alright, so that would be 40. Yeah, let's just do it over here. Why not? 40H plus, because you still have to pay this, 20H. Okay, but then we can combine these. 40H plus 20H is 60H. Okay, so there's scenario 1, buying. Scenario 2, renting. And we want to know when will these two be the same. So we just set them equal to each other. Okay. Now if you had a calculator, you could say n solve. So menu 3-1. Put all this in parentheses, comma h, and this would spit back an answer. But that's not very fun. We could do this the algebraic way, get h by itself. So we would combine them. So we bring 20h over to this side here. Right? So we want to get h all by itself. So 20 minus 20 cancels. 60 minus 20 back to 40 equals, we just bring this 80 down. So 40 times what number equals 80? And if you don't know that, for some reason I don't understand, we can divide both sides by 40. 80 divided by 40 is? You're not helping.
What?
80 divided by 40.
2.
Good, it's 2. Okay, so how many nights, H nights would it take? 2 H nights. Okay, there's our answer. That was more work than I thought it would be. Alright, one down. Number 2, what does mean absolute deviation describe? So mean absolute deviation, that's when we took the average, right? And then we subtracted each number from the average, and then we took the average again. Remember that? It was a lot of fun, and by fun I mean work. And the whole point of mean absolute deviation, so the answer, I'm just going to type it because it'll be easier for you to read. Mean absolute deviation describes how far, if I could type, how far away each number is from the mean. Period. Also, it describes how spread out the data is. Let's throw in some more words here. Also shows how Now it's a proper sentence. Okay. So that's what mean absolute deviation's for. Shows you how spread out it is. Sort of like the range, except slightly more useful, which should be more useful because there's a lot more work than range. So there it is. There we go. Write that. You might want to pause. Write it down. Alright, number 3. Which of the following preserve congruence? So this is talking about different transformations, right? So since we're talking about transformations, we need something to transform, which is why we have this disgusting thing here. And we're gonna transform it a little bit. So we're gonna call this A. Figure A. Okay? Nah, not that kind of transformer. So we're gonna take this, and our first one is rotation. So if we rotate, so it's facing the correct direction, to be giving a high five, is it still the same thing? Same shape, same size? Yes or no? Yes. So does rotation preserve congruence? Yes. Okay. Now go away, evil rotated cat. How fun is that? Deleting cats. Okay, so now we're going to make another one. Okay, reflections. We're going to take our figure A and we're going to flip it. We can go left to right or up or down, either way. Let's go left to right. Alright, settle down. Is it still same shape, same size? Yes. So does reflection preserve congruence? Yes. Okay. Now the fun part. Goodbye, cat. Alright, next one. Translate. What does it mean to translate something? No, not a different. Different kind of translation. Translate means slide. Yeah, pay attention. It's 8th grade math. Okay. If we just move it somewhere else, is it the same cat? Yes. This is going a lot slower than I thought it would. We're going to have to practice. Okay. Go away, cat. I didn't really need to do that, but I like it. Alright, dilation. What does it mean to dilate something? Or? Okay. Good words. Or make bigger or smaller. So if we were to take this cat and make it bigger and bigger and oh, hold on, and bigger, is it the same shape? Say yes. Is it the same size? Absolutely not. So did dilating it preserve congruence? No. Cuteness erased. Okay. So dilation would be a no unless that's an extra marker. Whoops. It's getting worse. Unless the scale factor is 1. But if the scale factor is 1, it's hardly a dilation at all. Alright? That's it. Alright, next one. Are we seriously on number 4? Okay, let's go quicker. Spacecraft was launched in 2011 on a 5-year trip to Jupiter. There is Jupiter. There is Juno. It will travel 2,800 million miles. On average, how far will it travel each year? Okay, so if it goes 2,800 miles, a million, we can ignore the million for right now. We want to average it out, so we need to divide it by how many years it travel for, which would be 5. 5 goes into 28 5 times. Again, you could do this on a calculator, but I don't have one handy, so this is quicker. 5 goes into 36 with nothing left over. So that gives about 560 million with an M miles. per year. Which is pretty far. Doesn't seem like it, 560, no big deal, but this million after is a lot. Alright, so now it wants that answer in scientific notation, because this whole paper is terrible. That's why we give it to you. So let's say, what's 560 million as just a number? So we did this before. Our first three numbers takes us to 1,000. The next three takes us to millions place right here. So we just throw 560 million right there. And then scientific notation. We need a number between 1 and 10. So we put this decimal between 5 and the 6. It started out at the very end. How far did it move? 3, 6, 7, 8. So our final answer is 5.6 times 10 to the, what did we say, 8 miles per year. Hooray, that was pretty easy. It goes faster when I don't ask the old lady for help. She's not good at math. Alright, number 5. This question shows up all the time. A ladder, 10 feet long, against a building. Bottom of the ladder 6 feet away from the base. How far up the building does the ladder reach? Okay, so if we're not sure how to do this, we start off. We draw a perfect building. We label it as such. Building. I know it looks like building, but no, that's a U. Building. Look, it's got a door. Okay, building. Then we have a ladder. Yes. Okay, and we have the ground. You know it's the ground because it's green. Now what we've made here, sort of, hopefully your drawing's better than mine, is this makes a right triangle because we assume the building to be perpendicular to the ground. It's not an artistic building, obviously. We can fill in some numbers here. The ladder is 10 feet. Bottom of the ladder 6 feet away. That's this number down here. Question is, how far up the building is it? So we don't know that yet, so we need to give it a name. So why not call it H, because that seems to be our mystery variable of the day. And if we have the missing side of a right triangle, we talked about this, the formula is a squared plus b squared equals c squared. Right? And we know the side across in the right angle, which is 10, has to be c. So this is 10 squared. A and B are the two legs, our two short sides. Order doesn't really matter, but I'm going to call A 6. And I'm going to say B is the one we don't know. Okay. We do the math. 6 squared is 36. Plus something equals 10 times 10, 100. Anytime you're looking for one of the short sides, instead of adding the two squares, we subtract them. So 100 minus 36 gives us b squared is 64, right? And then since it doesn't make sense that our 10-foot ladder would go 64 feet up a building, so we take the square root of both sides, and we get b is exactly, the square root of 64 is exactly 8. So how far up the building does our ladder reach? 8 feet. And you say, why does it keep giving us this question? When would this ever happen? And the answer is all the time you use a ladder. Because if you need to get on top of a building, you need to have the correct size ladder. Ideally, you don't want to bring a 50-foot ladder to our 10-foot tall building, or however tall this is. Yeah, or something. And the whole point of getting the ladder is obviously so we can rescue one tiny cat. And we're going to dilate it with a less than 1 scale factor so it can be tiny enough to fit on the roof. And then Wait, no. There. He's just sort of standing up there. Alright? So that's why you need to know Pythagorean theorem. So someday you can collect a cat off the top of a building. Okay? Here's your extra credit opportunity. I should see this cat underneath question 5, along with a building and a ladder. Okay? Do this. Draw this, if you haven't already. Not the purple circles. Okay. Number 6. What is the square root of 115 closest to? So you can put this in the calculator, and this is a trivial question. But if you want a history lesson of what 8th graders used to have to do, so you'd have to say, what perfect squares are closest to 115? So you'd be like, well, 9 squared. Where do I want to put this? 9 squared. Wait. Oh, that's been a while. Not 9 squared, just 9. What square root gives us 9? That's 81. And then the next number after that is 10. The square root that gives you 10 is 100. Right? That's not 115 won't fit in between there, so we kept going. Right? So the next number would be 11, and that would be 121. Okay, 115 is somewhere in between 100 and 121. What's it closer to? Well, it's 15 away from 100 and 6 away from 121, so it'd be right about here. So we'd say it's closest to the number 11. But if you had a calculator, you just say square root of 115 and it would give you like 10.7, 10.8. And you'd still say, since it says integer, integers don't have decimals, so you have to put the integer value. Okay? Alright, number 7. If x negative 6 is a solution to this equation, what is x? Okay. So it's x comma a number, which comes from x comma y, which means negative 6 is y. Okay, that's about it. We bring everything else down, so we have 2x minus 4 times negative 6 equals 10. Again, if you were so inclined and had the technology available, you could say and solve this mess for me, comma x. So we're using real variables again, and it'll tell you what x is. But I don't have a calculator in front of me, so we have to actually work this out. So 2x we're going to leave alone. We have negative 4 times negative 6, and negative times a negative will actually make positive. So you can say this ends up being plus 24. Bring the rest down. So 2 times something plus 24 equals 10. Now if we stop here briefly to think about it, we're adding something to 24 and getting 10. Alright? So whatever we're adding is actually bringing the value down, which tells us that x is going to equal negative something. Right? This has to be a negative number because it's bringing the value down. Okay? And if you think about it a little more, you can probably figure out what x is without having to do any extra work, but we're just going to go through the steps anyway. So to get x by itself, we get rid of this plus 24. To get rid of plus 24, we do the opposite, which is 2 subtracts. This cancels out. That gives us 2 times x. 10 minus 24 is negative 14. Hey, there's our negative. To get x by itself, we divide both sides by 2. 14 divided by 2 is? 14 divided by 2 is? 7. But it's one of them's a negative, so that is negative 7, which is our answer. And you could check that if you want to. You could put it back in here, but I'm going to tell you that's right. Okay? Alright, number 8. K equals yx is constant proportionality, which is a nice fancy name. It can also be referred to as the. This is a typo. I know it's a typo. I'm going to print it out with the typo anyway, because then it seems more Shakespearean. Like, what is the constant of proportionality? I don't have a very good British accent because I'm from America and I only speak American. Okay? Whatever. What are we doing? Okay, constant proportionality. What this comes back to is y equals kx, right? Where k is the constant, right? Why is k used for constant? Maybe because the people who made it came from the Mortal Kombat universe where there are no C's and only K's. I don't know. You can look it up if you want. They don't know how to spell because they're math people? Possible. So K, this letter next to X, right? Hopefully this is familiar. Sometimes we refer to this as M, right? Y equals mx. That might sound a little bit familiar, or a bit more familiar. So what is M? What does M stand for? That's right, slope. Right? So what's another word for slope? We already said M. How about rate of change? Okay. And then I'm going to stop and I'm going to give her time to think about this third one. We'll come up with something hilarious. I tried to get her to think about it, but she won't stop talking about what she read on Facebook. Wait, what? Katie, say unit rate. Unit rate. That's right. Unit rate is our third answer. And it's not Facebook, it's Reddit. Whatever internet medium you're getting your news from. So 3 things represent your constant of proportionality, or M, slope, rate of change, unit rate. All the same thing. And this formula is the same as this formula, just rewritten so that K would be by itself. Okay? Alright, number 9. If C is a function of n and n equals all this mess, is the following statement true? The value of n is dependent on C. Okay. This one just looks kind of bad. So this, instead of saying C and n, y equals, we say if it's a linear equation or function here, the only one we know of is mx plus b, right? And that's what we have here. So C would represent y. C is y. Okay. And n would be x. So does n, which is x, so does the value of x depend on y? Does x depend on y? Does x depend on y? Yes. And the answer is no. Mostly because Katie said yes, and I just assume she's always wrong. But the answer is no, because we know x represents the independent variable. And y is the dependent variable. Which literally means y depends on x. X is independent of y. Okay? So you can't say the value of x depends on y. That's backwards. You'd say the value of y depends on x. So the answer for this one is no. Okay? Alright, number 10. Tree grows 7 inches per year. Good for the tree. Seems kind of slow, though. That's probably true. I don't know enough about trees to argue. Write an equation describes the situation. So it grows 7 inches per year, right? Would indicate a unit rate, which we just established a couple questions ago was m, right? In our form y equals mx plus b. Okay? So all of our equations in 8th grade look like this. When you go to algebra, it'll be more complicated. For right now, just stay with this. Okay, so y equals m, our slope, it tells us, is 7x plus what? Where did our tree start? It doesn't tell us anything. So we use a little bit of common sense. Okay. Before the tree started to grow, how much it had grown already? The answer is not at all, because it hadn't started to grow. Okay? Don't try to get like super technical. Be like, well, what if it was a sapling and we planted it in our... No. It's not how tall it was. It's how much did it grow. Okay, so at time 0, it hadn't grown at all. So here's our equation. More simply, is just y equals 7x. So that is our first part. Does it pass through 0, 0 or 0, 7? So when x is 0, what does y equal? So what does 7 times 0 equal? That's 0. So does it go through 0, 7? No. It was not 7 inches tall when you started. It was 0 inches tall when you started. That's 0, 0. Look, it looks like a are you serious kind of face. You see that? Oh, if you don't see it, let me make him happy for a second. Yeah, right? Give him some eyebrows. Give him some messed up eyes. Okay, what are we doing? 0, 0. I'm just gonna put a box around it. Now he looks like he's got a mask. What is the slope? What? Why is it asking us this? We already established it. It's 7 inches per year. If you want to get technical, really, it's 7. What does the slope represent? Seriously, what are these questions? It's where we started. It's not a very good box, but this is frustrating. Why is that a question? The slope represents how much it grows. By it, I mean the tree per year, which is 7 inches, which gives us this equation. It's like the same thing, like over and over again. Okay, that's it. All 10 questions. It only took us 27. Oh, we'll try to go faster next time. All right, like and comment and upvote, whatever you kids do with things nowadays. Okay, bye.